to get minerals, and we want to have it so that it's got good protein. We're not finding less protein or a discount on it. Generally, if the plant is putting lots of sugar off its roots, it's feeding free-living nitrogen-fixing bacteria that make nitrogen for it. And so the protein is being taken up from the bacteria right now to make reasonable protein wheat, which could be 13%. But it's like pushing a rope. Even when you put lots of fertilizer on, hoping for high protein, you might have 8%. Protein. It's just really difficult to know. But the reason with that would be is you had a lot of rain and you washed your fertilizer away and you had no bacteria there to make protein at this time. Right now this plant is sucking up protein from free-living bacteria that's making higher protein grain, hopefully. So Geoff should take a test sample from here and we'll test it and find out what's the difference. And also do a mineral test, nutrition test, because I believe that a plant that's working with the fungus more, you'll have more nutrition. Yeah. And heavier grain weight. A lot of people have noticed that the test weight is heavier because if you have a lot more copper and zinc and iron in your grain, that's weight. And plants are made of 90% CO2, 6% hydrogen, and 2% nitrogen, and 2% minerals from the earth. So this plant came from the air. All the roots, all the top is from the air except for 2% of the earth. So when we think of that, we can make plants grow quite well. We're just stimulating them to take more out of the air. And so in order for this plant to make its own fertilizer, it has to take more CO2, make more sugar, and put more sugar in the soil to feed the fungi and the bacteria to explore the soil and bring the minerals to this plant to make nutritious food. This one, it's on ammonium phosphate. The signals to the plant is that there's a lot of sunlight energy placed into the soil. So the plant doesn't become positively charged, it's more negative because it's got more phosphorus and more chloride that's negative. And that's what attracts CO2 to the leaf, is more minerals on the leaf, make it have more potassium, more copper and zinc and iron, that's more positive. So the static electricity, CO2 is floating around in the air in this field at 400 parts per million. And that plant has to take it all out of the air. How does it do it? It's by attracting CO2 to the leaf to photosynthesize at a great rate and make a lot of sugar. So sugar comes off to make its own fertilizer. So when it's on ammonium phosphate, it's ammonium feeding. So ammonium is positive, phosphorus is negative. So they both go in the plant. And the plant doesn't pull in as much copper and zinc and calcium. And it's not feeding sugar, it's actually shutting down and making sugar. So the plant is producing less sugar in this plant than this one, because this one has to grow similar to this one. So it's using the sunlight more on this one because I placed sunlight into the soil as fertilizer. So this one switched and used the sun more, became more positive, sucked up more CO2, made more sugar, fed more microbial life in the soil. Has to. So it's plant physiology that we're working with. And it's all influenced by the tractor putting smoke in the soil that is the stimulation. So I'll explain it more on my presentation.
Are we taking and not giving back? Or how does it replenish itself?
Okay, I'll just hold this part here. Okay, this one here, you say, is not taking. Okay, it's fertilizer. This one's been fertilized. It's not taking anything. This one's greedy. It's really taking a lot, right? Where's it getting it from? It's getting it from that thing up there. That's sunlight. This one wasn't taking anything because you gave it. So fertilizer is stored sunlight put into the dirt. So this plant sensed there's a lot of sunlight energy under its roots and it doesn't want to burn itself up, so it stops making energy go off its roots. This one here says, I'm really hungry, and the bacteria and fungus send hormones to the plant to drive your roots out more, become more positively charged, get more minerals up, get potassium up there to open up the stomata. Don't put chloride up there. This guy's got chloride and phosphorus up there, and chloride has closed the stomata so it doesn't take in CO2. So this one's a sugar factory. This one is using, this one here is a synthetic supported energy plant that came from fossil fuel that you got to pay for. 100 gallons of fuel, no fuel. Just, you know. So it has to get its energy from somewhere, and everyone says it's going to run out of energy if you don't use fertilizer. But this one has been physiology change to use more sunlight. So you can see it's still got green flag leaves. This one, look at the flag leaves, different. Look at this one. This factory's still going on this guy. Still green, eh? And this one's done because phosphorus is a maturity molecule. It just matures it quicker. It's important, but I don't want to have too much.
So you worried about chemical applications and things like that, stopping that?
Yeah, and I don't want to put on anything that's going to be offensive to this biological system working. I want this plant to have maximum microbial life in the soil. So sometimes some of the chemistry we use tie up minerals that are important to these bacteria and fungus work.